Law of energy. The change of internal energy is equals to Q, which is heat, minus work, minus W is equals to work. In isovolumetric process, W is equals to 0. So that means that change of internal energy is equals to heat equals to Q. In isobaric process, it says that work is equals to pressure times change in volume. And in isothermic process, change in internal energy is equals to 0. That means that Q minus W is equals to 0, where W is equals to Q. In adiabatic process, Q is equals to 0, which means that if we write the formula for the law of energy, change of internal energy is equals to Q minus work, where Q says that it is 0, so change of internal energy is equals to negative work. In isovolumetric processes, there is no change in volume, and in isovolumetric, an example would be a bomb calorimeter, where a combustion reaction produces a change in temperature, but the rigid walls result in no change in volume. If there is no change in the temperature of a system, there cannot have been any change in the internal energy of a system. Since two volumes are proportional, delta U will be 0, which makes Q is equals to W. This means that any heat transferred into the system is used by the system to do work, rather than increasing the internal energy of a system. This is called the isothermic process. Meaning no change in temperature. An ideal version of a car engine would be an example for this, as the piston ought to convert all the heat energy from the combustion reaction directly into expansion work that moves the car. If there is no heat transferred, Q will be 0, and delta U will equal negative work. This means that the internal energy of a system changes as a result of doing work on its surroundings, or the surroundings doing work upon the system, such as a process will be called adiabatic process, meaning no heat transferred. We can see this in a certain process in Earth's atmosphere, as mass of air changes position due to the pressure differences. And if Q and W are both 0, meaning there is no heat transferred and no work done, there can be no change in internal energy, and this must be an isolated system. We will also need to define the signs of these quantities in order to use this equation properly. Let's note that when heat is absorbed by the system, Q will be positive. If heat lost by the system, Q will be negative. So If work is done on the system by the surroundings, like gas compression, W will be negative. If there is no transfer of heat or no work done, these values can be also equals to zero, as we have previously discussed. When doing calculations, make sure that you use the correct signs for these values or the math will be incorrect. For example, if 100 joules of compression, work is done on a system, and as the result of internal energy of the system increases by 74 joules, how much of the energy is transferred as heat and in which direction? Let's take our equation and rearrange to solve for Q. So we write change of internal energy equals to Q, which is heat, minus W, where W is equals to 100 joules, and Q is what we're going to solve, and change of internal energy is 74 joules. We can write this as Q is equals to Q is equals to 74 joules. 74 joules. When we write this, Q is equals to 74 joules minus 100 joules. Then Q is equals to negative 26 joules. We should get negative 26 joules for heat. This means that as 100 joules of work is applied to the system, only 74 goes towards increasing the internal energy of the system, while 26 joules are lost as heat dissipates out of the system. So, you can solve a problem where the given R work is 300 joules, and Q are missing, and internal energy is also missing. And we must know that isobaric says that work is equals to pressure times change of volume. And volume says that work is equals to 0. And isothermic change of internal energy is equals to 0. And adiabatic, where heat is equals to 0. Our given is the atomic gas. This is what we're going to use for the gas constant with constant pressure is equals to 7/2 R, and the constant volume is equals to 5/2 R. So the personal thermodynamics says that work is equals to Q. We're going to do isobaric first. We know that Q is equals to N C P junction T. is equals to N C V junction T. And this is our from the Tesla thermal low energy source to junction and energy source to minus work. Then it says that probably is equals to N CP junction T, which is Q, minus N CB junction T. To simplify, probably is equals to N junction T CB minus CP. Given is probably then R so to solve for Q and the internal energy, you can say that Q is equals to M 7/2 R, where 7/2 R is the change of pressure. And change of T. Multiply by change of T. This is equals to 7/2, and we know that nRT is equals to 300 joules. We will multiply this to 300 joules. Joules of heat. The change of internal energy is equals to N 1/2 R change of T. Where this is 5/2 and the nRT, which is 300 joules, is equals to 750 joules. We are done on isobaric processes, and we will move on to isothermic. Where change of U is equals to T minus W, where change of internal energy is equals to 0. That says that 0 equals Q minus W, where Q is equals to W, and Q is equals to 300 joules. Next is WRT process. Where Q is equals to 0. Change of U is equals to -U, and change of U is equals to -300 joules. Remember that in isovolumetric, O is equals to 0. So we're not going to do this because Q1 here is 300 joules of heat, and we're only looking for the Q and the heat and the change of internal energy, which is the internal energy from the adiabatic process, which is negative 300 joules, and the Q is equals to 300 joules. equals Q equals result equals to 0, 8 equals